So in this reaction video, I'll be discussing our lab experiment on performance specifications of second order control systems. So to start, let me briefly go over what we did and our output. So in this experiment, we analyzed how different parameters like dumping ratio, natural frequency, and dump frequency affect the system's step response. So we used a MATLAB to simulate these responses by changing values such as sigma and omega d. From the graphs, we observe how the system transitions from undamped to underdamped and eventually overdamped behavior. So, for example, when the damping factor R was low, the system showed oscillations with higher overshoot. So as the damping increased, the oscillations decreased and the system became more stable. So we also calculated the key performance metrics like percent overshoot, peak time, and settling time. So our computed values was very close to the simulated ones, which confirmed the accuracy of our formulas. So additionally, when we added zeros and poles, we saw how they influenced the system's response, where zeros affected the shape and speed. So while additional poles influence the stability and the dominant behavior. So now for the challenges, one of the main difficulties I encountered was understanding how each parameter, so especially in damping ratio and damping frequency, individually affects the shape of the step response. So it was also challenging to interpret graphs at first, especially distinguishing between underdamped and overdamped cases. So another challenge was connecting the mathematical formulas to the actual plotted results. So however, after running multiple simulations and observing patterns, it became clearer and how these concepts are related. So, lastly, some notes to myself. Always remember that dominant poles determine the overall behavior of the system. So, and second, increasing damping reduces overshoot but can slow down the third response. So, and third, adding zeros and poles can significantly change system performance. So their placement is very important in design. And lastly, simulations are very helpful, but it's important to understand the theory behind them to properly interpret the results. And that's all. Thank you.